Hey, we back. We're still doing this. I did decide just to have these as two separate ones because it was long last time. It was long. So I've had a closer look at this. I didn't actually change that much at all, which is what I said, to be fair. One thing that I did end up changing is adding this in here. This was just Lamvar, and I was quite confused about that, if you remember. I didn't think it should just be Lamvar, and it turns out it shouldn't, so that explains it. It's meant to be this. So, sure. At any rate, though, this apparently is the thing that it's meant to be. This apparently works, so that's good. As for our little test that we were doing last time, this thing here, where it was not getting Lamvar 3, as you can see, I ended up getting the Lamvar 3. And what I actually did is rewrote the input. So that was an interesting one, because that means that actually the input either is wrong, or it's not passing the LAMAPs properly, not reading the order properly. So I asked around, I tried to figure out which it was, and it turns out it actually was the wrong input. So this is partly good and partly bad. It's partly good because it means that this works, apparently. Which is good, obviously. We want it to work. That was what I was hoping for. So in that case, we can move on. We can go to the next bit. We've got our single substitution thing, right? And I need to figure out if it's inner or outer because I'm still not really sure, to be honest. But success, right? However, here's the problem. Here is the problem, because that means that up in our challenge 2, 3, 4 numbers, challenge 4. If you remember, we actually used the parse macro thing. Well, not that. This one. We used this to actually generate the arguments. And obviously, if it generated them wrong, then that means that this is wrong. So before we move on, I'm just going to try and fix this. Hopefully, it should not take too long. But let's look at the two inputs we've got. I wrote them both down here. No. Here. No. Yes. This is not it. This is it, though, I believe. So if I take this, and I shove it in here, let me just check. It's taking a while to load, because it's been a while since I told it to do anything, and it's just waking itself up, I suppose. I mean, that's fair. That's fair. I'll let it do that. Although, it really is taking a long time. Damn! It never takes this long. I assume it'll just take this long the first one. There we go, it works. Oh yeah, okay, I copied it with the thingies. Take 2. There we go. Now this should come up with this. I'm just repeatedly putting this through. I suppose you can come see, why not? So yeah, I put the first one in here. Then this is the second one, like that. Then we have the third one. There we go. We get Lamvar 3. So it works, right? What we had before did not work. That was the one where it was giving nothing at the end. 1, 2, 3 should be this one, which is this instead. No. Where is it? Oh, we can just check it actually. If I can spell. Class macro, and then I can just give it. Oh hell, I've got a lot of stuff open. Let me close some stuff like that and that. And this is going to be partly why it's slow. And close that. We'll put on some music as well while we're doing it, as always, and take the copyright strikes. There we go. Now we have our examples, which is this. There you go, without the N. Don't know why I put that in there. Right, so this is what it is giving, and this is what we're getting. So let's just compare these two in the file over here. So we have this. And we have this. So you see this has got lamap and then first. Wait, where's the first? Oh, I didn't copy the whole thing. Okay. That's fair then. There we go. No, not like that. There we go. So this has first, then lamap 3, lamap ID 4. Whereas this has lamap first, bar lamap macro 4. So you see, the lamap is in the different order. So we need to go through the parse lambda expression and make sure that that's existing. Now I just heard my Discord go off, so let me shut it up for the rest of the video. There we go. That should no longer be making noise. Okay, so we have these two. Let's copy these. We can bring them up with us to our parse lambda macro expression thingy. Where's the actual function? Here it is. So I'm going to shove them in these so it doesn't kill itself. Right. Let's put them through here, right? So, oh yeah, I should put the input as well, I guess. So what we're giving it is first x3 id x4 as a string, right? There you go. Okay. So it's taking this string, and then it's parsing it here, right, which works fine. Oh yeah, because of all of this obviously is just checking that it's valid, right? So let's go up to where it's actually parsed. Shove it here. We're just going to move this up with us as we go, basically. So it's going to search for the macros. It's going to search for the expression. Right, yes, because of course it does actually get past an actual lambda macro, technically. But obviously the macros are going to be empty, and they are, it does at least do that, so we're looking for parse expression on this. Yes, this should just be an expression. Alright, another layer up to go, parse expression. So, what have we got? Oh yeah, of course we got actual parse expression as well. Wait, does this skip straight into parse expression or the? Okay, yeah, no. I just misread it. It's fine. So we get this. So we've parsed this, right? And basically it is checking if it can find an application, and if not, then it goes down a layer, right? Obviously it finds an application. Because application is expression 1 string expression 2, right? So expression 1 should be first, and then expression 2 should be this, right? So let's see, this is the one that it's giving, and this is the one that it should be giving, right? That's what I said. Where is it? Here it is. It should be giving with the lamap. Yeah, so it should be giving this, and it's actually giving this. Given that, let me turn this down a little bit. There you go. So, debugging time. It is looking for an expression with a string. Where's macro? It looks for var first, then it looks for abs, obviously neither of those. It looks to see if it's got something in brackets. It does have something in brackets, which does go under the string, but it's got this first, so no. And then it checks for a macro name, which it finds. Yeah, that seems correct. So then it should be saying lamap. I think I found the problem. So it should be saying is a lamap of this and this. What it's saying is it finds a macro name here. I think maybe this needs to be in a different order or something. Right. Let me just do some testing with this. So if I shove this on, we can do. Let's first just check that this is doing what it says it's doing. Right. Yeah, exactly. So that's wrong, but yes. So it finds the application between this and all of this. Oh yeah, because that's what I said, isn't it? But that's not correct. It should be an application between... Wait, is that not correct? Let me go have another look at the examples on here. Where are they? Here we go. No, here they here. So let me pass it something like this. See what it says to this. Oh dear, that already had things. Because I thought that it did these correctly. So it should have lamap, lamap, lambar, lambar, lamacro. It has lambar. Yeah, it's doing this wrong. But I tested these before. I tested these all before and they worked fine. So what is the problem now? Have I changed something since I did this? I'm not going to go back and watch the video or anything. I mean, I assume you saw it. If you've got to this part, why would you watch this one without watching the others, huh? Go back and watch the others. Of course, no one's actually watching this part, so it's kind of irrelevant, but, you know, that's the idea. Anyway, this is wrong. So we found what our problem is. It's actually just doing the brackets wrong. It's meant to be application of lambar 1 with 2 and then f. So what it's done basically is it says it's x1, x2, f, like that. What it's meant to be is x1, x2, f, right? It's put them the wrong way around. Which is why I say probably this is the wrong way around here. So it looks for an application, which obviously it finds, and then a parse expression. Ah, I see, it's looking for brackets then. Doesn't find any, it finds parse var. How does it actually find the second bit then at all? Because then what you parse it... Oh, I need to look in parse app. Ah, I see, because this is this. This should be able to be a parse expression, right? What if I just swap these around? What are you going to do then? Well, it's going to compile. Looks like it's going to get stuck. Okay. Yeah, it just crashed at the moment. It's eating a lot of my CPU and it's not stopping. Yeah. And there goes the music. I did tell it to stop. Okay, well, that's fantastic. Basically, let's not do that. But because you've got parse app, this, the first bit in this, needs to be an application, right? The first one needs to be an application. Am I just going to need to shut it down? I think I am. I mean, CMD. I was kind of hoping to keep it open so I could see my old command history and all, but okay, I guess we shut it down then. I'll reopen it again in a minute. So, we pass it the three things though. And yeah, it should be doing lam app and then with a lam app inside, but it finds the lam app and then this can't be a lam app. This needs to be able to be a lam app, basically, right? So how does one do that? Because like I say, if I make this, the problem is if I do this, then you pass it a variable, then it'll always just assume it's an application, right? Even if you just pass it x1, it'll say, oh yeah, it's an application, it'll just loop. By saying the first one can't be an application, then it stops it looping. And the first one can be an application if you have brackets, that's what it's saying. But the first one should be the second one. So yeah, I need to somehow swap it around. I need to make it so the second one can only be an application. Which is why I thought doing something like this. But then this loops into here and loops into here because it's all lazy, right? It never gets to this bit. What if I swap these two around as well? I wonder what that would do. Only one way to find out, I guess. Let's open up CMD and see what that says. Computer's still being very slow. It really didn't like when I just gave it that thing that looped forever, huh? Really didn't like that. Now it's trying to open Minecraft as well, which is not what I asked for. Oh dear. I typed it wrong. You can come over and check out what's going on over here though. I accidentally didn't put the H, but I think it'll work it out anyway, it normally does. Yeah, no, that's fair. I think that's the thing we can do. Yep, there we go. Ah, that's interesting. So this one just assumes that this is a lambar and then doesn't even try to find an application. Yeah, okay. It makes sense that it would do that. But then if I say to find an application and then pass it a lambar with it the other way around, it'll assume it's an application. See, this is the thing with this one. It does at least work. Well, I swap them around for things like this, right? You've got lambar, right? It's just then you add an x3. It should be lamap, right? According to this thing.
Next time you do this, you could
Lamap. Yeah.
Yourself, Matthew.
Oh dear.
The witch must die.
What's going on, huh? Okay, wait, this has found another music now. Yeah, I think I'll do my normal, where I go away and take a closer look at it and come back later, because after all, it took me a long time to get this working in the first place, and obviously I didn't actually get it working, which is fantastic. Alright, I've been staring at this for... I stared about 4 hours, 4, something like that, a while. And, yeah, didn't make much progress. I took a bit of a break, I come back, and I thought, we'll do it step by step, right? So, for now, we've got this stupid thing, and basically, it will pass, well, if you come over here and have a look, it passes this correctly, this correctly, this correctly, this correctly, it doesn't pass this one correctly, because this is the point. I've got it up to x6, and then you see it does this. What I need to do is make that infinite. But so this is the one for x3 and x4 and x5, and then you see there's no x6 one. If I added another one of these and another one of these, then it would do x6, but I can't just write infinite functions on here. I need to somehow recurse this so that it'll actually do it infinite times, which is what I'm going to work on at the moment. So we're going to start just by saying, okay, well this is parse expression 2, so we're going to take parse expression 2 and just replace it with that, right, and parse expression 3, replace it with this, and so on. And this is kind of what I was just planning on doing. I just thought I would chip in that little update there, so you can see what I'm kind of going through here with these stupid expressions. Hopefully I'll try and simplify all of this down, right, and make it so it's all one function, and then I'll have the ordering that I need, because yeah, but this works right up to x5, x1 to x5, all applications, it does it left recursive, it's fine, but then it starts trying to do right recursive, and for some reason that errors it as well in this particular setup that I've got, which to be honest is fine, because right recursive is not the way that's doing it anyway, and I have checked the errors aren't errors in the actual code when you give it something that is not, that would not cause it to go right recursive in any situation. As far as I'm aware, it works and it doesn't error. It's just erroring with the right recursive stuff, so sure, whatever. Anyway, this is what we've got at the moment, and I'll continue trying to sort it out for a bit. Alright, the next little update that we've got is going to be this. Main progress is down with this. This is now this, instead of the long thing that it was. We stopped putting the silly amounts of ticks on the end of everything. And then this is nicer, at least. So it's basically just, it either does expression space, and then this is just a based expression, and then this is the tear down, right? Or it just does the tear down and it skips to there, right? And it just keeps on doing this till it gets to the bottom. But obviously then, what if you need a tear up from here? You need to write another one of these. It's a lot easier to add another tier now than it was before, when you were adding one of these and adding the little expression thing that I had here, and changing this. Basically, all you would need to do now is add the extra tick there, copy paste this with an extra tick there, an extra tick there, an extra tick there, and an extra tick there. So yeah, not too bad, but still not quite what we're looking for. Obviously, it's still not actually properly, recursive yet. Not really sure how to make it recursive either yet. Another hour or so goes by, and yeah, I'm thinking the thing is, what I need to do is make it so that this, instead of calling the tear down, calls itself, right? Something like this. But obviously that wouldn't work because it would just keep looping into itself, now it's infinite, right? So I need to have it not do that. But that's the kind of thing that I'm looking for. Mind as well that doing that is basically exactly the same as the code that I had originally, ages before I even started, which is annoying. Well, the same functionality anyway. The difference a tick can make. But hopefully this is closer to what I need it to be. Hopefully I'm getting there. I don't know. I'll continue working on it, I guess. Alright, well, significant time has now passed. So I mean significant time. I spent far too long looking at all of this yesterday. And, yeah, let's just say it was not fun. I believe I now have something that works. I'll go through a couple of the things that I tried and kind of explain what I've got now. So the thing that I was doing before is what you see here, which is now commented out, and I'm actually going to delete it in a minute because it doesn't work. Or at least it doesn't work how I know. So obviously I managed to remove all of the parse expressions, tick, 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 and just had parse app, so that's good. We did it in this form with this at the end here each time, and so then in order to go down a step, or rather to do an extra step, we would add an extra one of these with 4 ticks. You basically just copy paste this, right? So let me do an example. There you go. Here's another one, and then done. It now does an extra step. Oh no, wait. Now does an extra step. I didn't need that one. And that's it. That's all you do. And that was working, but I could not find a base case for it, and therefore I couldn't get it to actually recurse properly. So basically, was not happy. You would technically need these as well. So, in that case, what could I possibly do to make it work? So I tried a couple of other things. In the end, I actually created 5 separate and individual parsers, which includes the original one and the one that you saw in the middle there. But there was 5 of them, and all of them were right recursive. And of course, we need a left recursive one. That's how that works. So I kept at it. I did very much almost give up. midway. I was extremely annoyed with it, but you know, I continued going for a little bit, and I came up with this, which if you ignore this bit, because this is the bit that actually does work, we had this. So you would do expression 1, pass expression 1, expression 2, pass app, expression 3, pass app, expression 4, pass, so on, as many as you like, and then you return, and you just manually create the lam apps. Right, you see this one's just 1 lam app, this is 2, we had a third one here with 3, and that would have pass expression 4, and this was basically the same as this. You know, it works. It was actually left recursive, but only for a certain number of steps, and then it would swap round, the same as this one. Now, I could keep adding them quite easily, whereas this one would need, I mean, what's this, 6 lines of code, and a couple of extra ticks each time. What this needed is 1 line of code extra for each step. So you see, the first step here only takes 3 lines of code, then this takes 4, the next one will take 5, 6, 7, so on. So if you're trying to do 10 steps, you're adding like 14 lines of code for each one. So it gets a bit massive. But on the other hand, they're all contained in the one function, which is kind of nice. And then I thought, I was just trying to think of how I could possibly make this recursive. I actually managed to think of this idea when I was trying to do this thing here, which doesn't work also. I tried to take what I had as the left recursive one, but it is infinite, and I found a thing on Wikipedia that converts it from that and removes the infinite thing, and I tried to do the conversion, and it worked. And I created something that was right recursive, so that was great. And that was using this. And then, yeah, like I say, I came up with this, which makes it left recursive for a bit, and then swaps after a certain number of steps. But I managed to actually make this recursive by doing something really stupid and cursed. So it still takes this first one from pass expression, as you see. It's the same as this, basically. But then what I remembered is we have the many function, right? So instead of just saying expression 1 is pass app, expression 3 is expression 2 is pass app, expression 3 is pass app, 4 is pass app, whatever, it just does many. It takes all the pass apps possible and just shoves them in expression tail, which is now a list of expressions, right? Which is why it's really stupid and cursed. Yeah. Then we let expression final equal this stupid function here, which takes the first one and the list of the other ones. And this is what this is doing here, make app. So this is where the recursion is, right? We take, if you pass it just one expression, as in this passed, but then this, there was nothing, right? So then it just returns E1. If there was one of them, it returns, the two combined. And if there was a bunch of them, it recurses with the two combined here and this. This is the rest of the list, and then this becomes the E1. And so this basically creates this thing here in a function, right? If you think about it, if you pass it something like this, you'd have expression 1 goes here, this becomes E1, and then goes into lamap E1 and E, which is the first element of this list. Then it recurses with makeApp, shoves this in, this goes in the first half of the application, the rest of the list goes here, you put the lamap. See, it works, right? But it's recursive, so it works. So I basically created this, but with an actual base case, because I used the many function, and as far as my testing has gone, this works. So now I just need to remove all the redundant code, because obviously, for example, this is not being called anywhere anymore. All of this is commented out anyway, so we can just remove that. We've got parse app. Oh yeah, this is the other thing. Parse app no longer has its first expression, so it is now just string and parse expression. Spacebar, sorry. It's the string spacebar and then parse expression. So the downside of this is I think it would pass spacebar x1 or something as an application and kind of die, and we'll probably need to go and fix that, but that should not be too hard. We can just put some error checking in. So yes, Now, this can die, this can die. I feel like we probably don't need that, but I wouldn't be surprised if we do. So, what I'm going to do for now is just try this, see if it works. So if you just pop over here, there we go. We can reload that. You can see the testing that I was doing before. This is just the tests that we get. These all worked fine. I also was testing my transform function on a couple of things. Just because, I guess, I don't know. It's taking a while to compile, isn't it? That's odd. And before it was stuck on something. I don't even think that's possible, but yeah, who knows. I suppose if you had something that was recursively generating code, maybe? What do you think? Nah, I don't think it's possible. It sure is taking a while, though. Damn, can you get on with it, maybe? It is actually starting to worry me. Do you think I might just force close it and get up a new one, you know? What I'll do is I'll start getting up a new one. If it still hasn't compiled by the time I've got up the new one, I'll just close it. And do it on the new one instead. Wait, which one are you even going to be seeing now? You're still seeing the old one. So what if I kill the old one? You see the new one now? Yeah, okay, sure. So let's see if this does it any faster, eh? I hope so. Did I just kill it? No, okay. Huh. When I click off it stops flashing. What fun. There we go, we got it. Right, so. Pass expression. Let's just try x1, right? Fine. x2. Left recursive. Still left recursive. And then let's just add a bunch. Still left recursive. You can tell because all the lam maps are at the start. Right? So basically, it works. Now, what if I randomly change one of these in here to be, say, lamabs? Well, I suppose we could have lamabs 5. That's the one we removed. What if we do something silly like that in the middle? Yeah, it dies then. Oh wait, no, I know why it dies then. It's because I'm retarded. I haven't slept enough, clearly. This is the parser. We're meant to write it in the nice language. There we go. This is cursed here. Also, wait, why is there a space at the end? I suppose it's passing it like this. There shouldn't be a space at the end. That was my bad. I didn't mean to do that. But it's fine. You can tell it's working anyway. Because it's put in the space. The point is, if this was in parse lam macro, it would fail. I'm pretty sure. But it doesn't matter. Because I could just remove the space. Right, we've got all the lam apps still, and we get lambar 1, lambar 1. Lam apps, lambar. Yep, that's still working perfectly fine. And then what if I shove in here something more complicated? We could have, say, something like that. Got all the lam apps at the start, we've got these. Yeah, that works. Oh, that's correct. I mean, that's completely correct. Just going to remove this just so that I don't. So it looks a bit nicer. How could we possibly make this more stupid? randomly adding brackets to one of these, I guess. So we have all of the lam maps. We get number 1, all but 1. Number 1, number 2, lam map 3, 4, lam maps 5, 5, 6, 7. Yeah, it's correct. It's perfect. It's perfect, and it's correct, and it's beautiful, and it's working. That took too long. Like, way too long. I mean, if nothing else, it is the next day now. So, do with that information what you will. Alright, so, yes, this looks good. This, I mean, it's cursed. Because, what the hell is this, basically? Oh, what the hell is this? When I first wrote that, I print screened it and put it on Discord. Because, like, that's just, I mean, it's stupid. It shouldn't be a thing. But, yeah, there you go. Anyway, this, I believe, is now working as intended, which is good. Actually, very similar to the one that we had at the start, which is what I said it would be. But now with this, because sure, and also the thing has been removed from here. So there you go. Can confirm right recursion significantly easier than left recursion. Yeah. So then, given that, we go back to challenge 6. Now, I cannot remember how much of this we did in the actual start of this, because I don't think we got that far. I was thinking about moving this whole fixing it thing into a video by itself, just because it was clearly not chapter 6, and it went on chapter. Oh, I've not slept enough. Challenge 6 was clearly not challenge 6, and it was becoming quite long. But I also thought that partly I can't remember how far through we got. Can't be bothered to go back and watch the recordings. Stop this recording and start another recording later. All silliness. So, long story short, we're just going to keep this all in one video, and we're going to go back to challenge 6 now. Because, why not, I guess. Why not? In which case, I need to figure out what the hell I was doing with this chapter 6. Because I can't remember. I do not have a clue. So, yeah, let's have a bit of a look here. We were doing the substitute. The inner red N. And we had all of these silly cases. Yes. Yes, quite. Well, let's try running some functions then and see what it does. We know this compiles because it's the same program as before. So let's just try running something. What are we passing this? A list of macros and then an expression. Okay. So let's have the list of macros can be F, and that can be lamabs1, number 1, simple identity, and then here we'll just have like F applied to x2. That's not how that works. This is F. Yeah, we need a lam app here. We can add lambar2 here. See what that does. Doesn't work. Fantastic. Could match string expression with actual type car. Right, yeah, no, that's a fair point. We need brackets here. Okay, so what do we get? It has expanded the f. And then, if you take this, shove it in here, and bar 2. Perfect. So this is what we were looking for, right? Now, let me pop on some music. Oh, this is going to be loud. I'll turn it down once it gets on.
We've missed this house as well, love.
It's time to search at all.
Great, add that. Fantastic. Very nice.
Here we go.
There you go.
Let's start.
Okay, now let's go find that example we were looking for before.
I'll give you. Listen to me. Stay in your lane. All of your talking.
This is the one we had.
Nails on a chalkboard. Nails on your face. You make me want to. Voices in my head telling me.
Okay, so first let's pass this, because if you remember, this is the original problem that we had that made us go back to the stupid challenge 2, 3, 4. Ah! Yes. There we go. So now we get this. Oh dear. What's wrong? You want another brackets? No. What's the problem, huh? I'm just gonna copy this into Notepad and write it on here. Wait, it's probably already here actually. I did write a bunch of stuff. Yeah, here it is. Ah, yes, and this is the other thing we had. Right, let's, you know what, let's check this is equal now. Wait. No, this is not what I want. Okay, hang on. I want to take this, pass it, and then I'm gonna take this, and then I'm gonna put on the end equals equals I know you can't see this, don't worry, neither can I. Boop. True. So this is what I actually wrote. It was very hard to write without actually being able to see it. But yes, we had, yes, so basically I have just checked that the thing that Land Macro is printing out is the same thing as what we want now. And it is. So that's good. Given that, let's start reducing this. So if I just take this, 1, right, 1, two. Copy it again, shove the output in. Three. So, here's the magical thing. That is meant to take 4. So where's the extra one? Let me have a look at the example. It's first x3, then id x4. So first it needs to expand out that think I see the problem. It totally is skipping a step. Because it expands out first, right? So here, this is the one with the first, right? It expands it out to this. This is first. And then we just have lamvar 3, the macro ID, and the 4. Then after that, it realizes that if it's taking the first from, so this takes lamabs 1, lamabs 2, and returns lambar 1, right? So it takes the lamabs 2 and it returns, sorry, it takes the lambar 1, which is just this. It's just shoved all of this into the lamabs, which, you know, that's correct. And then it has lamabs 2 remaining, so then it just gets rid of the second half without even evaluating it. Which is magical, to be honest. I'm not really sure how it's... Well, I know how it's doing it. I'm not sure how I would make it take more time, you know? It's just kind of... It realizes that... It's correct, you know? It's not doing steps that it shouldn't do, it's just doing the steps in the wrong order. I wonder if it's meant to expand out all macros before it starts or something, which is kind of completely unnecessary, but that would make sense. On the other hand, I don't know how to make it do that. So, suffice to say though, if it was doing inner reduction, it would be doing the ID bit first. So I'm pretty sure it's outer reduction. But I'm also pretty sure that it's magical. So, I'm going to have a think about that for sure. Yeah, I'm gonna have a look. The other thing that we can do though in the meantime, well no, see the thing is we've got this other test that would either take 4 or 3, depending on if I've written inner or outer reduction. But it's very similar to that last test. I'm looking at it, it's going to take 3, I can see that. Because it is literally exactly the same as the last test, but the ID is actually written out already. So the point is, if you're doing... wait, does that actually make sense? Because if you're doing inner reduction, how could it possibly take 4? Oh, come have a look, come have a look. That's black screen. That's still a black screen. There we go. There we go. You can see that now, hopefully. So this is the point, this is what we've got. And we have, in here, we've got first x3 ID 4. This takes 4 steps for inner and 4 steps for outer. It's just for mine it takes 3. Yeah, I don't know why it would not. If you do outer reduction, surely this... If you do outer reduction, then it should first do this, and then, like, just take the first, which is x3. It doesn't need to know what's in here. Whereas if you do inner, it's gonna expand the ID, apply the ID to 4, then expand first, then, oh yeah, that's a good point. Surely it'd be 5 then. Because you're doing 2 extra steps. Oh, what? Because you first have to expand ID, and then you have to... Wait, unless applying first is all one step. No, because look, first it takes 2 arguments. So one step is putting the x in, and one step is putting the x2 in. And mine does that in 2 steps. That's fair, but that's its 3 steps. Expand first, put x1 in, put x2 in, and it ends up with x3. That's the whole thing. It's done now, you know. But inner is first going to expand ID, then it's going to put x1 in on ID, then it'll expand first. So it's 3 steps already. Then it puts x1 and x2 in, that's 5. But apparently we're meant to get 4, so, yeah, interesting one. And then what about this here? See, this here is the same, but we've got this written out already. So the point is, with inner reduction, it doesn't make a difference. In outer reduction, it takes less. Surely these are the other way round. Surely. Because with outer reduction, it's not expanding this anyway. And inner reduction, it would be. So it saves it some time. That's what I would have thought. Yeah, this is kind of weird. What I'm going to do is I'm going to ask about it, and then when I've got some fresh answers, I'll return. It's Edit Boy here, and I'm here to say that this video is a lot longer than I realised it was. Actually, all in all, it's 4 hours. I normally try and keep them at kind of maximum 2, even for these silly Haskell ones. But the midpoint of this just isn't a nice place to split it. So I'm going to split this into 3, an hour, then 2 hours, and then 1 hour-ish. Hence, this is the end of this one. The next one will be up tomorrow, and there will be continuation of after I have talked to the said people. Alright, bye!